So a vector field is essentially a vector function of a type where basically you're looking at some function p of xy, q of xyj, both in 2D and R2 and on R3. So essentially what I want to do is get you to quickly understand what these, how to get an idea of how you draw vector fields. It's practically done usually on a computer, but one needs to understand how they are drawn, at least in the 2D situation. So here's an example quickly of a vector field. As the name suggests, a vector field is in fact not, obviously we're not talking about one vector. We're talking, so basically what's going on is you're looking at minus y and x, okay, as your vector. Now, if you want to get an idea of what we're really talking about, the best thing is to construct a little table. So we have the values of xy, okay, and the values of f, the vector field of xy. So let's do this little table here quickly. For instance, if we look at the value, for the sake of argument, 1, 0. Now 1, 0 gives me the x coordinate. So what's happening is the x coordinate is minus y, so it's 0, and the x coordinate is 1. Okay. Now if I look at in the same way 0, 1, then I'm looking at minus 1, 0, because the y coordinate, as you see here, y, negative y, and x. So what's happening is this is negative y and x. Okay. If you like, I'll write it for you over here. What we have over there, the definition is as follows. Okay. So let's try another point then. For instance, let's say 1, 1. 1, 1 becomes in fact minus 1 and 1. Let's try another one, say 1, 2. 1, 2 becomes minus 2 and 1, and so on. Now, that's not the point. There's no point in collecting all these till we actually see what in fact is happening here. What is in fact a vector field? So what you do is the following. So you look at the point xy, for instance here. This is 1, 0 is the coordinate. So this is 1. And okay, so this is 1, 0, so that means that's the point 1, 0. And you draw the vector 0, 1, but you imagine as if your crosshairs are at this point. So in other words, you think that this is your 0, 0 when you're drawing the vector, essentially. Okay, so that means you're drawing a vector 0, 1, so it's 0 in the direction of the x-axis, and it's 1 in the direction of this. So the point in this case it would be 0, 1, so it's going to be this point. Now on these axes 0, 1 would be here. Okay, it's 0, 1 would be here, but that's not what I'm telling. I'm telling you this is now, imagine 0, 0, then this would be the vector, okay, which starts at the point the xy we chose. Let's try another one. Get the hang of it, hopefully. 0, 1 means 0, 1 is this point here. This is 0, 1, and the vector we're drawing is minus 1, 0. Minus 1 means that the x coordinate will go, this is minus 1 over here, this is 1 over here, and this itself is plus 1. Now, minus 1, 0 means that it's going to be over here, in fact. So minus 1, 0 from here would mean this. But I know, in fact, you know yourself that actually on these axes it's over here, on the x-axis minus. So hopefully you understand that what's going on is the origin is the point, is this xy point that we're looking at. Okay, so this xy point is the origin, is like the start of where the vector begins, and then you draw 0, 1 over there. So let's try another one. Say 1, 1. Now 1, 1 means that you're looking at this point here, and I'll put it in yellow. So maybe you can see it. So there's the so there's that vector. There's the point 1, 1, and the vector is minus 1, 1. So minus 1, 1 means from here 1 this way. So 1, 1 is minus 1, 1. So minus 1 means in the x direction, you're in the x direction we're going to go minus 1. So it's to the left by 1 unit. Okay, so it's going to be from here, we're going to be left 1 unit, and then it's going to go up to by 1 unit. So it's going to be up here. So it's this point. So this means that we connect these, and our vector turns out to be this one. So that's our vector. Okay, that's our vector. Okay, next try another one. The 1, 2. 1, 2 means that 1, 2 on this axis would mean 1 and 2 up here. So that's this point. Okay, that's the starting point. And it's minus 2, 1 we have to plot. Minus 2 in the x means 1 to the left, 2 to the left, and then 1 up. Okay, so that means it's going to be here. This is 2. This is 3. So it's going to be minus 1 and 1 here, and then up here. So that's the vector we're looking at. Okay, so in this way, what you can see appearing is a field, in fact, of vectors. Okay, this is called a vector field because it contains lots and lots of vectors, in fact. Now, if you can go further, do several more examples, like for instance, the vector here is a vector that goes down by 1 unit, okay? And the vector over here is a vector goes this way by 1 unit. So what you've got is some kind of a circling going on, for instance. So what this does is it starts to show you, like flow patterns and so on of vector fields. Now, I'll show you a couple of examples from the Stewart book. So here's the idea. This is again from Stewart's calculus. Okay, this is from Stewart's calculus. So again, you can see here there's several more, and you can see this circular pattern going on. The vectors it looks a little bit smaller there, but let's see if I can make it a little bigger, but you won't be able to see much. But anyway, there, as you can see, what's going on is these vectors here. These vectors going in this direction, and so they seem to be circling, representing some kind of circular motion, like a vortex of some kind. So this is called a vector field, okay? Which, as you can see, it's a field of vectors. So many vectors in it within just a minus 5 to 5 and minus 5 to 5 on the xy plane, and you can see so many vectors here. So this is called a vector field. So here you'll see a three-dimensional example. Now this is next to impossible to try to draw by hand, but you can see on a computer it looks quite interesting. And you can see that could be some like it looks like air conditioning or something. A wind, the sort of air coming out of an air conditioner or something, or it could be a weather chart which shows how the different temperatures are changing, or the wind is blowing, and so on and so forth. So what you see there, the example, as you see again this is from Stewart's calculus. Sorry. So this is also from Stewart's calculus. So again, you'll see here a very interesting three-dimensional plot of a three-dimensional vector field, in fact, as you see here, y minus 2 x. Hopefully you understand what vector fields are. Let's move on. Okay, so a gradient field, we revisit the concept of the gradient, if you remember. So the grad of some f of xy, okay, if you remember, gives us basically fx xy, okay, and fy xy for a two-dimensional case. Now this, as you will see, this in fact is a vector field, and it's called, it's referred to as the gradient field. So these are gradient fields, in fact. So this is great. These are gradient fields. So, and you can do the same for some function of f, which is xyz, and that would be then your fx, fy, and fz. So since these be three functions of xyz, that also constitutes what we refer to as a vector field. So a quick example would be like, for instance, you have if we stick with the three-dimensional case, we might have, say, x squared y squared z squared. Then the gradient of f, in fact, turns out to be the x derivative, which is 2x y squared z squared. Okay, and then you'll have the y derivative, so it's 2x squared y z squared, and similarly 2x squared y squared z. So that actually would constitute a vector field. That is an actual vector field and is referred to as a gradient field. Now the applications of this are so many. Vector fields themselves help us to understand magnetic fields as well as gravitational fields. But as I said, we're not We might look at those applications later on in a different video. Thank you.